Get started. So today's topic of discussion will be waves. Right. So first, can someone tell me what is the definition of it? So what is the definition of a wave? It is a disturbance, right? So it is a disturbance created in a medium which carries energy, from one place to another, is called a wave. Right. Next is, if it is going to be a disturbance which is going to carry energy, how is it going to be with respect to the displacement equation of a wave? Okay. So, see, I'm actually directly getting into the content. I'm not describing the basics and all. I'm not going to talk about mechanical, non-mechanical and all. If you want, I will explain it. Do you want me to?
Sir, அதெல்லாம் நியூமரிக்கல்ல ரொம்ப இன்வால்வ் ஆச்சுன்னா ஓகே சார்.
Numerical, it is not going to happen. It's not. Definition. Okay. So now I'm concentrating only on numerical part. Okay. So displacement equation of a wave, when you write, see, generally when you write the equation of a particle in oscillation, right, that is simple harmonic motion, you write y of t is equal to a sine of omega t plus phi, right, where a stands for amplitude, omega stands for angular frequency, phi stands for initial phase, or it is also called as epoch. Right, it is called initial phase or epoch. Right, this is the equation of a particle in SHM. So when I talk about oscillation, okay, so when I talk about an oscillation, there is going to be a particle which will have a to and fro motion, right? It is going to have a to and fro motion, but it is going to have a to and fro motion only with respect to a fixed point called as the mean position. So this is amplitude, this is an amplitude, right? So any other part in between is what is the displacement y, which I'm trying to talk about. Right. Now the question is, when I want to talk about the displacement of a wave which is traveling, okay, displacement of a wave which is traveling, it is also called as a progressive wave or traveling wave. Okay. So what is the difference between oscillation and a wave which is traveling? That's what we need to understand. So with respect to a wave which is traveling, what will happen is the particle will oscillate about its mean position and the energy will get transmitted. Right? So that is what is going to happen. So if you want to write the equation of a progressive wave, this you would have seen this year. You would have seen this kind of an equation, but in terms of electric field and magnetic field and EM waves. So the displacement equation of a progressive wave, I'm stressing on this point, please make a clear note, of a progressive wave will not be a function of one variable, rather it will be a function of two variables. What are they? It is a displacement along x direction and the time, which is given by the equation a sine of kx minus omega t plus phi. Right, we would have seen this equation this year, right? Electric field along y direction is equal to E naught sine of ky minus omega t plus phi, something like this. You would have seen, right? So this equation and this equation are similar. That is what I'm trying to say is, if you're able to understand this, you can apply the same logic to a problem based on electromagnetic waves also. I hope you made a clear note of it, where y stands for the displacement of the particle. Okay, X is obviously displacement along x direction. T is time. A stands for amplitude of the particle. K stands for what, guys? Can you tell me?
Angular wavelength.
Angular wavelength. It's not wavelength.
Wave
It's
number.
called, yes, it's called angular wave number. So what do you mean by a wave number? Wave number is the
Number
reciprocal of
of waves
wavelength. That
per
is
unit length.
per unit.
Length. Sir.
Very good. So K is equal to 2 pi divided by lambda. It is measured in radian per meter. Okay. Similarly, omega obviously stands for angular frequency, phi stands for initial phase. One last important point to be noted is when a wave is traveling in the positive x direction, then you will have a minus sign here. So the negative sign indicates energy is getting transmitted in which direction? Wave is progressing in positive x direction. Okay. I hope you're able to understand this. So omega is equal to 2 pi by t or 2 pi f. We have used this in the last chapter. That's not an issue. So only thing we need to be careful with is wave number. So wave number is generally represented with the symbol nu with a bar on top of it. It's not V, it is nu. It's a Greek alphabet. Nu bar. That is K. Radian per meter. I hope I'm clear. Any doubt?
No, sir.
Good. Now comes an important question. So in the previous, let me link it to the previous chapter so that you'll understand the difference. So if I give y is equal to a sine of omega t plus phi, if I ask you velocity, okay, listen to my question carefully. If I ask you to calculate velocity here, what would you mathematically do? You
Take
will
the derivative.
differentiate it with respect to time and you will get it as a omega cos of omega t plus phi. Now I have a question. This dy by dt, yes, according to the definition, it is velocity. It is the velocity of whom? It is the velocity of whom with respect to a simple harmonic motion. It is the, listen to this carefully, okay? It is the velocity of the particle which is oscillating. Okay. In a similar context, what I have written is the thing I have replaced is I have written something called as a progressive wave. Sometimes we call it as plane progressive wave, or it is also called as traveling wave. Okay, I understood this. Now the question is, if I write the equation of a wave which is going to be function of two variables, right? So here observe, in oscillation, y is only a function of time. A very important point to be noted. It is not a function of displacement, right? Whereas in the case of a wave, it is a function of time and displacement. So with respect to y, I can perform two operations. I can perform dy by dt and dy by dx. Now I need to have a clarity of what is this dy by dt going to represent with respect to a wave. Can you guys tell me? Right? Okay, one simple question. Okay, if you answer this, you'll get the difference. You'll understand what I'm trying to ask. With respect to oscillation, what is happening? The particle, there is only one concept. What is that I'm trying to talk about? I'm talking about particle. Whereas when I talk about a wave, I'm using the word displacement of particle, and I'm talking about a wave which is progressing to the right. So particle is oscillating in y direction, and the wave is propagating in the rightward direction. Wave is propagating means energy is getting transmitted. That is the meaning. Okay. If that is the case, then if I do dy by dt mathematically, that is mathematics. According to physics, what does it represent?
So it's the velocity of the particle that created the disturbance.
Very good. It is the velocity of particle. Here, there is another thing that is going to happen. It is not only particle that is involved. There is something else also involved. What is it? There is something called as velocity of wave also. Okay, this is where people get confused. So when a displacement equation for a wave is given, that displacement equation is for a particle, not for the wave. Okay. So when you differentiate the displacement equation of the wave, you are actually getting the velocity of the particle. So questions will be twisted. In the question, they will ask you what is the velocity of particle. Sometimes you do a mistake of finding the velocity of wave and write the answer. That will also be there in the option. They'll confuse you. Okay, so be careful about it. I'll tell you how to calculate the velocity of wave. Okay, next is, if I do dy by dx, what am I going to get? This point I've stressed many times. If you differentiate something with respect to time, we call it as
Rate.
rate. If you differentiate something with respect to distance, we call it as
Gradient.
Gradient.
yes, you call it as a gradient. And what is the technical name? Gradient is also called as slope. Am I clear? Now listen to this carefully. So if I have the equation y of x comma t is equal to a sine of, see, whatever concept I'm going to teach is the way you need to solve the problem also. So listen to this carefully. If there is any doubt, let it clarify. Okay, well, there's the equation. Here, whenever two variables are involved, you cannot differentiate directly. Rather, you would perform a differentiation called as partial differentiation, which is represented like this. It is written as dou y by dou t. Dou is also Greek alphabet. Okay. If I do dou y by dou t, how many variables are there? X and t, no? Means t is treated as a variable, x is treated as a constant. Okay. Now tell me what will be the answer. A times, what is the derivative of sine? It is cos of kx minus omega t plus 5 into, we need to perform chain rule, dou by dou t of kx minus omega t plus 5. In the kx minus omega t plus 5, which is variable and which are constant? Constants.
Minus omega t is a variable.
Variable. Kx is a constant and phi is a constant. So what will your answer be?
Minus
Minus a omega. Yes. Cos of kx minus omega t plus 5. If you observe, it is something similar to what you get in the simple harmonic motion also. Yes. So this is the velocity of particle. I hope this is clear. So let this be equation number 1. Now I have another question. If I do dou y by dou x, I'll give you a minute time. Can you guys do and tell me what is it? What it is?
Sir, I have a doubt, sir.
Tell me.
Sir, dy by dx, you said is only the velocity of the particle, right, sir? Not the velocity,
Yeah, velocity
of
of
the wave.
particle. Yes.
So
Yes.
the y equation also, the y of x comma t is also only displacement of a particle, not a wave.
Particle. Yes.
Okay.
Okay.
Sir, Ka cos of kx minus
A
omega.
times k cos of kx minus omega t plus 5. I hope this is what you would have got. Everybody got this? Any doubt?
No, sir.
Right?
No, sir.
No. Now listen. If I divide the second equation with the first, what am I going to get? I'm going to get dou y by dou x is equal. Okay, I'll do one thing. I'll divide the first with second. Not necessarily you have to remember which one to be divided by other. You can try whatever you want. So velocity of particle divided by dou y by dou x is equal to what will get cancelled and what remain. You directly tell me, no? Cos kx minus omega t multiplied with a will get cancelled. So what is that I'm left out with? I'm left out with omega by k. Omega is 2 pi by capital T and k is 2 pi by lambda. 2 pi gets cancelled. Lambda goes to the numerator. So the velocity of particle is equal to negative of lambda by t into dou y by dou x. What does lambda by t or lambda into f represent? You would have learned this in atomic
Displacement
structure.
by time.
Yeah, displacement by time. What is it actually? Displacement by time is, see, this
Velocity.
wavelength, yes, wavelength, name itself says wavelength. So wavelength is a term associated with wave, because if you go and revisit the previous chapter, in simple harmonic motion, you will never use the word wavelength because there is no wave at all. The energy is not transmitted. So wavelength divided by time is going to give you what velocity? Wave velocity. So here, can I write it like this? Particle velocity is equal to negative of wave velocity into, what does dou y by dou x represent? It is the slope of the curve at a given point. That's what differentiation tells us. So this is the most important formula or expression, however you want to take it. Most important thing for you to remember when a basic question related to a wave is asked. Okay, this is what we are going to concentrate first. Is there any doubt, guys? I hope it is clear.
Yes, sir. 1 minute, sir. Can I copy it?
Yeah, right.
Sir, so in questions, if they ask for the velocity of the wave, then do we write the wave velocity or the particle velocity? Wave velocity, right?
Wave velocity, whatever they ask, you have to write that velocity. See, wave velocity, it is actually lambda by t. I have written it here. No, lambda by t is nothing but omega by k. If I do a reverse analysis, this omega by k has what has given me that lambda by t. Correct? If I do the reverse analysis.
Yes, sir.
So when they give you a question, for example, if they give you a question like this, y is equal to 5 sine of let's say 2x minus 5t plus 5. If I ask you the wave velocity, do you need to sit and do all these things? What will you do? You will generally compare it with the standard wave equation. Then omega will be 5, k will be 2. What is your answer? Are you able to understand?
Yes, sir.
Okay. So generally, see here that since I dealt with the general variables, I got this big expression. But when they give you a problem, right, you will have numbers. So things will be simple.
Sir, so wave velocity is also omega by k, sir.
Wave velocity is also omega by k. So there are two formulae. What is it? One is lambda by t. Actually, wave velocity has three formulae. What are they? Lambda by t is also wave velocity. Lambda into f is also wave velocity. And omega by k is also wave velocity. So this concept, this expression, we use it in the dual nature of matter and all those things, especially the atoms chapter in 12th standard, right? There we are going to deal in the form of waves and all. Wavelength comes into picture, then we'll be using them. Okay. Shall we do some problems? So there is a question here. You guys try, no? There is a progressive wave which is traveling along the positive x direction represented by the equation y of x comma t is equal to a sine of kx minus omega t plus phi. Its snapshot at t is equal to 0 is given in the figure. For this wave, the phase phi is how much? It's actually a simple question. It's pure maths question. You can look at it and tell.
I
Sure. What is your answer? Is it pi? Tell me, no? Is it pi? The answer is yes. But what is the reason?
sir, it's a sine wave, but then it doesn't start from the.
It is a sine wave, but the wave they have given is the mirror image of the sine wave. Yes, right? It's a flipped image. So sine will change its. So sine of something will change its sign only after it crosses pi plus something. Where after it enters the third quadrant. That is why I told it's a pure math-based problem. I'm repeating it, guys. Listen to this carefully. Okay. You have learned functions, right? So what is a function? See, okay. You would have heard about even and odd functions, right? Can someone tell me what is an even and odd function?
Odd function is f of minus x is equal to minus f of x.
Minus
Even
f of x. That is,
even
yes.
f of minus x is equal to f of x.
Yep. Yes. Can you give me an example of it?
Sine and cos.
This is, yes. Odd and even. The best example is sine and cos. Right? So when you take a function f of x like this, if it is an odd function, okay, then how will it be? Then how is minus f of x? It will be symmetric with respect to, so remember it like this, okay? So what I'm trying to say is, generally an odd function will be symmetric with respect to the first and the third quadrant. The negative of the odd function will be symmetric with respect to the second and the fourth quadrant. Purida? Am I clear? Or you want me to explain it?
So can you just repeat?
Listen. If you see a graph like this, okay, I'll change the graph. If you see a graph like this, is this an even function or odd function?
Odd function.
How did you say? By looking at the graph.
Sir, அந்த x1 intersection point பார்த்து சும்மா minus 2 plus 2 சும்மா போட்டு பார்த்தேன்.
Okay, இதுதான் பண்ண தேவையில்லை. See, if this question comes in maths, right, especially in integrals, if they ask you something like this, area கண்டுபிடிக்க சொல்றாங்கன்னா, then what you can do is take a plus and a minus sign. If this is minus pi and this is plus pi, if I directly ask you a question, integral of minus pi to plus pi, whatever this function f of x dx, you can directly say the answer is 0, because with respect to integrals, area represents with a sign, correct? I am able to look at the graph and I am able to say it's a odd function. There is a property kuda, correct? Minus a to a integral of f of x dx is equal to 0 if f of x is an odd function. You can go and recollect and see. அது ஏன் சொல்றாங்க அப்படின்னா, odd function is generally symmetric with respect to the origin. அப்படின்னா, this first quadrant, it will be symmetric with respect to the third quadrant. So if I put a negative sign for it, you have to draw the lateral inversion of it. அப்படின்னா, for example, if I call this as f of x, then what will this graph be?
Minus f of x.
It is minus f of x. You're able to understand this? So the same thing has happened with respect to this graph also. They have given it as sine function, but what have they actually drawn? They have drawn minus sign or something. So sine will become negative for the first time after it enters into which quadrant?
Third quadrant.
So third quadrant means pi plus something, correct? That is why the answer is pi. Are you guys able to understand the application of odd and even functions? Right? Okay. Shall I proceed?
Yes, sir.
Okay. So next problem is actually based on Doppler effect. Let's do it later. This is based on Doppler effect. Just come in this. Wait, let me look for another problem with respect to a standing wave. String 20 centimeters suspense short pulse created. This time taken. Okay, this one will not work. Let's do 6th, 7th, and 8th. See, there is a transverse. Do you guys know what is a transverse wave? Yes or no? Let's make it fast. Do you know what is a transverse wave? So transverse is generally used for perpendicular. Perpendicular for whom? It is something like this. Wait. So transverse wave means vibrations of particle is always perpendicular to direction of propagation of wave. Okay. What is the counterpart of transverse? It's called as
Longitudinal.
longitudinal. Okay, the best example of a transverse wave is an EM wave. If you recollect, I would have explained in the case of an EM wave that it is a transverse wave. Remember this, okay? The same thing will get repeated in wave optics also. There is one topic that is removed from your syllabus, which is polarization. In that, we will be using it as transverse wave. Remember this carefully. The example of longitudinal wave is sound. So in a case of a longitudinal wave, vibration of particle is always in the direction of propagation. Okay. Now listen. So what are they trying to say? There is a transverse sinusoidal wave which moves along a string in the positive x direction at a speed of 10 centimeter per second. The wavelength of the wave is 0.5 meter and its amplitude is 10 centimeter. At a particular time t, the snapshot of the wave is shown in the figure. The velocity of the point P when its displacement is 5 centimeter is how much? Let me copy this question. You guys can read it again. It's actually a good question. Sorry. So what have they given? They have given some speed, right? Read the question carefully and tell me what that speed represents. Tell me, da. So what speed have they given? Transverse sinusoidal wave moves with a speed of 10 centimeters per second. So wave velocity is how much? Plus 10 centimeter per second, right? The wavelength of the wave is how much? 0.5 meter. Its amplitude is how much? 10 centimeter. That is 10 into 10 power minus 2 meter. At a particular time, the snapshot is shown. The velocity of the particle when the displacement is 5 centimeter. So what is going to be the equation? Y is equal to a sine of kx minus omega t.
Sir, so dy by dt.
Yes. So the velocity of the point P when its displacement is 5 centimeter. So when x is equal to 5 centimeter, what is going to be the velocity of the particle?
Sir,
That's what
minus
they're asking.
lambda by t into dou y by
That's
dou
it.
x.
So minus omega
சார்
by
நம்ம
k,
ஃபேஸ் டிஃபரன்ஸ் ஜீரோன்னு எடுத்துக்கணும்னு எப்படி சார் தெரியும் நமக்கு?
because it's starting here. It's a sine wave. See, had the wave started here, அப்படின்னு பார்த்துன்னு வச்சுக்கோ, இங்க வருதுன்னா, so what does that phi represent? Initial phase, correct? Phi naught னு எடுத்துக்கிட்டேன்னா, it is initial phase. So when you're representing something in the form of sine, correct? So sine initially at t is equal to 0, how much is it supposed to give us? It should actually give you a 0. Whereas if I look at this, it is not 0. You know, this is something from the sine of something plus pi by 3, something like that. It is shifted. Purida. So if the wave exactly, if it is represented as sine, nalla purinjukko. If it is represented as sine, and if the graph starts exactly from the origin, then phi naught is 0. So velocity of the particle is minus omega by k into dy by dx. At what point? At x is equal to 5 centimeter. Can we do this?
சார் அப்பனா காஸ்க்காக இருந்துச்சுன்னா இட்ஸ் நாட் அட் ஆல் பாசிபிள் ஃபேஸ் டிஃபரன்ஸ் டு பி
No,
ஜீரோ.
you can இப்படி இருக்கணும் graph. If it starts like this, Okay, wow. See, simple. Y is equal to a cos of, you can write it like this also. Some books, standard books represent it like this, but for JE purpose, we use only sign based on questions. When you go for graduation and all, they use cos. What is this point? This is the point where x is 0 and t is 0. When you substitute it, what are you going to get? If suppose this is the amplitude, then if I write, what is this coordinate? It is going to be 0 comma a, correct? So in the place of y, you are going to write a. A is equal to a into cos of k into how much? 0 minus omega into 0 plus phi. A and a will get cancelled. So 1 is equal to cos phi, that is phi naught. So what is the value? Cos phi naught is, so what will be the value of phi naught?
0.
The same reason I use for sin also. Sin you will get the answer. Okay, purida.
Puriyudu.
So velocity of the particle is minus omega by k, they have given minus 10 into, what is dy by dx? Can you calculate and tell me? Oh, we need to find that kx minus omega t and all those things, right?
Sir, dy by dx or dou y by dou x?
Dou y by dou x. When I write dy by dx, that is the meaning. Okay, slope of yx graph.
Okay, sir.
See, actually, you can do this problem by trial and error method. I'll tell you a method. So in exam, you need not sit and waste all these times. What you can do is, if you see the particle is actually has started from its mean position, it is going upwards, right? Now, velocity of the particle is negative of some value into dou y by dou x, correct? And the value, that speed that they have given. I'm not sitting and calculating. So dou y by dou x means it is the slope of the curve at that point. Slope of the curve means you draw a tangent at that point. This fact we know. When you draw a tangent at that point, is the tangent making an acute angle or obtuse angle?
Obtuse.
Obtuse, correct? So when it is making an obtuse angle, that is going to be negative. So you already have a minus sign. This value is positive value into a negative value. So how much is answer? It is positive of something. And remember, when the particle is going up, its velocity is going to be in the downward direction. Okay. Sorry, not downward. I'm sorry. According to this question, I got positive, right? So the velocity of the particle is in this direction. Right? So in which direction is it with respect to vectors? Because I'm looking at the options. The vector is either j or I. According to the way we have drawn, what direction is the velocity?
Yes.
So this should be the answer. You need not sit and calculate actually, because all the values are same.
So how did you know that it was in the upward direction?
Because the particle has not yet reached the amplitude. It's simple. When you throw an object upwards, right? When you throw an object upwards, its velocity, I'm putting a question like this. Its velocity is going to be only the positive y direction till which point?
The maximum velocity.
Maximum point. Till its maximum height. So this is with respect to the influence under gravity. With respect to a wave, what is going to be the maximum height? It is the amplitude. So till it is going to reach its amplitude, this particle is still going to travel in the upward direction. So had the question been, see, suppose this question is being asked in your exam, if they make a small change like this, instead of saying positive x direction, if they use the wave is traveling the negative x direction, then what would have happened is minus is already in the formula. Okay. Then the velocity of the wave will be negative into dou y by dou x also would have been negative. Why dou y by dou x is negative? I hope you understood. Because when you differentiate, so differentiation means drawing a tangent at a particular point and finding out. So tan of an obtuse angle is negative because it's a decreasing function, correct? So negative into negative into negative would have been negative. So negative y direction would have been the answer. Then minus root 3 pi by 50 j cap. Am I clear with this?
Yes, sir. But in the
Mhm.
upward direction, that alone I didn't understand.
Upward direction. See, nothing. If I talk about a particle P here, okay, and the wave is traveling in this direction, forget about the wave traveling. This particle, where it would have started from? It would have started from the x-axis, right? So when the wave is traveling to the right, since this is amplitude, this will decrease and slowly this point will start increasing. After some time, how will the wave look like? Means the amplitude will slightly shift, right? Is it not something like this? So initially this is the amplitude. Now after some time, what would have happened? The amplitude would have got shifted to some other point, something like this. Are you able to understand? Now this point is the maximum point attained by P. So this P, whereas it has started from the origin, like let's say x-axis, it is traveling in which direction? It is traveling in the upward direction.
Okay, sir. Okay.
That's what I tried to explain using the maximum height concept. Okay.
சார் எனக்கு ஆக்சுவலி நீங்க அந்த மேக்ஸிமம் ஹைட் வச்சு சொன்னது டவுட் எனக்கு.
Tell me that.
சார் யூ செட் தட் லைக் அன்டில் இட் கோஸ் டு தி மேக்ஸிமம் ஹைட் தான் அந்த வெலாசிட்டி வந்து y டைரக்ஷன்ல எடுத்துக்கணும்.
Positive y direction.
எஸ் சார்.
After
பட்
it is
ஆனா
up,
ஈவன் ஆஃப்டர் இட் கோஸ் டு மேக்ஸிமம் ஹைட்னா கூட x டைரக்ஷன்ல ஒண்ணுமே இருக்காதுல்ல சார் வெலாசிட்டி.
but the particle will come down. இப்போ இது இங்க என்ன நடக்குதுன்னா, this particle is oscillating.
டைரக்ஷன் மாறும் சார். பட் ஆனா அந்த எக்ஸ் டைரக்ஷன்லாம் ஒண்ணும் வராதுல்ல.
அதுல வராதுடா. நான் எதுக்கு புரியறதுக்காக இந்த ரெண்டுத்தையும் கனெக்ட் பண்ண, அவ்வளவுதான். நான் என்ன சொல்றேன்னா, in the case of kinematics maximum height எப்படி பிஹேவ் பண்ணுதோ, I'm just giving a similarity of thought process, அவ்வளவுதான். In the case of a wave, imagine that this particle is going to the maximum height. What is that maximum height with respect to a wave called as amplitude? That is what I try to explain. If you are not convinced with this, forget it. No issue. But இதுல புரிஞ்சதுல, waveல புரிஞ்சதுல?
எஸ் சார்.
ஓகே
சார் அப்போனா வந்து லைக் இன்கேஸ் வந்து பி பாயிண்ட் வந்து லைக் இட் வாஸ் அந்த ரெண்டாவது
இங்க இருந்தா இங்க
இட் வாஸ் லைக்
then it would have been a downward
டைரக்ஷன். ஓகே.
Yes, downward. So that is only a, like we are trying to guess the answer. Like enna, without solving, we are trying to find the direction. Or else, if you want to solve and do, what you have to do is, it involves a lot of mathematics, because we have told you x is equal to 5 centimeter. No, you have to substitute x is equal to 5 centimeter here, then find the corresponding y value and then solve. You need time also. So it is a tedious process. Adukada I eliminated this. Okay, that's not the objective of these kind of problems. It's for you to find the direction. Okay, next. A traveling wave in a stretched string is described by the equation y is equal to a sin kx minus omega t. The maximum particle velocity is, it's very simple. So what is the maximum particle velocity? So the graph is like this.
A omega, sir.
A omega, that's it. So what you need to do is do dou y by dou t is equal to 0 and then solve it, you will get the answer. That's it. Okay. So one more idea to think is, I'll give you a key. Okay. Whenever you're solving a problem based on wave, you need to think like this. Particle is in SHM. So again, I'm stressing on the pointer. A wave consists of a particle and energy transmission. Particle is oscillating. When I say the particle is oscillating, particle is in SHM. So since they ask the maximum velocity of the particle, and since the particle is in SHM, whatever is going to be the value of maximum velocity in the case of SHM, that's the answer. So mostly what mistake you will do is you'll write it as omega by k. It is a omega. Is everyone able to understand this?
Yes, sir.
Right. One last problem. A transverse wave is described by the equation y is equal to y naught sine of 2 pi into ft minus x by lambda. The maximum velocity of the particle is equal to 4 times its wave velocity if. So let me write down the equation. So what is the equation? Y is equal to y naught. What is the equation? Y is equal to y naught sine 2 pi into ft minus x divided by lambda. What did they say? Maximum velocity is equal to how much? The maximum particle velocity is equal to 4 times the wave velocity. So maximum particle velocity is 4 times the wave velocity. Okay. So what is the maximum particle velocity according to the previous question? It is a into omega is equal to 4 into what is the value of wave velocity? It is omega by k. Correct? Omega gone. So a is equal to 4 into 1 divided by 2 pi by lambda. So lambda divided by 2 pi is what you're going to get. So this will get cancelled, which implies lambda is equal to pi a divided by 2. Is there an option like this? Pi a divided, here a is nothing but y naught. So answer is D. Guys, are you convinced? So pi into y naught divided by 2. Right? So this is all about wave velocity. This, I hope you guys can manage it. You can try out few more problems today evening. Seriya? The next concept that I need to explain is the concept of standing waves. This is where we need to be very careful. Listen to this very carefully, okay? This is a slightly confusing concept, but I suggest you all to listen to this carefully and get your doubts clarified. And most of the problems will be based on this. Okay. So when I talk about waves, I explained what is a progressive wave. Progressive means it is traveling. Then now I'm using a word called as standing wave, or it is also called as a stationary wave. Now, what is a stationary wave and how is it formed actually? That's what we need to understand. Okay, listen to this carefully. Before I explain what is a standing wave, we need to understand what is principle of superposition of waves. So this term is not new to you guys. We have seen it in many places. So what does principle of superposition mean? It means when you have a number of waves which travel through a medium simultaneously, then what can happen to them? They can superpose on each other, correct? Superpose means they can get added up such that the resultant displacement of any particle in the medium at a given point is equal to what? Is equal to the algebraic sum of the displacements due to the individual waves. So let's say you have two waves, y1 and y2. Then y will be equal to y1 plus y2 is the mathematical expression for whom? For the principle of superposition of waves. I hope this everybody knows, right? So listen to this carefully, okay? I'll read out certain points. When two waves of same frequency, in another, they are coherent. Okay, this term is also not new to you guys. When two waves of the same frequency moving with the same speed in the same direction a medium superpose on each other, they give rise to the effect called as interference of waves. This year we have learned interference, correct? So you go and revisit and see interference. What is the important condition? The waves are supposed to be coherent, correct? Next, when two waves of the same frequency moving with the same speed, but if they are moving in opposite directions in a medium superposed on each other, then they produce something called as a stationary wave. Third, when two waves of slightly different frequencies moving with the same speed in the same direction in a medium superposed on each other, then they produce something called as beats. Okay. This interference of waves has something to do with light. Stationary waves has something to do with sound. Stationary waves is a term used for designing a musical instrument. Adhe mari, beats is also a term that is related to sound. So in this chapter, if you see, though the name of the chapter is waves, we will mainly be discussing about sound waves because light waves is dealt in wave optics. Guys, tell me one thing. Are you clear with what is principle of superposition?
Yes, sir.
Are you clear with all the 3 points that I mentioned? Interference, standing waves, and beats. Right?
Yes, sir.
Now see. Now comes an important point. Now I need to discuss something about reflection of waves because a standing wave is formed by two waves which are traveling in exactly opposite directions and they should have the same frequency. That's an important condition to be satisfied. So if I take a wave, incident wave, which is of the form y is equal to a sine of kx minus omega t, okay, then when it strikes, so this is an important point to be noted, okay. So when this wave is striking a medium which is rigid, if it is striking a rigid boundary, then there will be a phase shift of pi radians. Please make a note of this. Then there will be a phase shift of pi radians. Whereas, if there is a wave which is incident on an open boundary and is reflected, then there will be no phase change. There will be no phase change. It again involves the molecular theory and all. Let's not get into those details. Let's have this in mind, as our objective is only to solve problems. Okay. So, if I talk, now I'm going to give you the expression for standing waves. Listen to me carefully. Okay. If I take the incident wave as y is equal to a sine of kx minus omega t. I'm not taking that phi into consideration. I don't want it. Okay. Then reflected wave, when I say reflected wave, it is going to travel in which direction? Now tell me one thing, guys. This is the first wave. Incident wave is traveling in which direction according to my
Positive
equation?
X.
So positive x direction. So if it has to be a reflected wave, it has to travel in a negative x direction. If I call that reflected wave as a sine of kx plus omega t, then it is going to travel in the negative x direction. That's what I understand. Now comes an important question. What will happen if they superpose on each other? Y is equal to y1 plus y2. Correct? So that is a into sine kx minus omega t plus sine kx plus omega t. Trigonometry, sine x plus sine y.
2 sin x plus y by 2 cos x minus y.
That's right. So it is 2 sine of x plus y by 2. Now what will you get? Kx. So omega t will get cancelled. So you get 2a sine kx. Correct? And you will have cos of omega t. I directly wrote it. Now if you observe this equation, I can either write it as 2a sine kx into cos omega t, or I will write it as 2a cos omega t into sine kx. Which one should I prefer?
So first one.
You will take the first one into consideration because what is the name of this wave that I told you? It's a standing wave. Correct? So this equation represents the equation of a standing wave. Why I am calling it as a standing wave is because if a wave is progressive in nature, you will have the equation as kx minus omega t. Whereas if I look at this first equation, if I replace 2a sine kx with some a dash cos omega t represents what? A dash cos omega t represents the equation of SHM, a particle in SHM. But what is the difference between a particle in SHM and the equation that I have in my hand now? And this one.
So dependent on external.
Yes. When you talk about a simple harmonic motion, the amplitude of the wave the amplitude of a particle in SHM is a constant. Whereas when you look at the equation of the standing wave, 2a sine kx, this is not a constant. It is varying with respect to distance. With respect to which distance? X distance. So when I say varying, then amplitude can have a maximum value, or the same amplitude can have a minimum value. Okay. So if I write sine kx is equal to plus or minus 1, then what is the general solution for this? What is the general solution for sine theta is equal to plus or minus 1?
N pi plus pi by 2.
It will be n pi. Is what a general solution? Is it a general solution? N pi plus pi by 2 will come for tan. N pi plus alpha.
Minus 1 power n.
Okay. Wait, I will do a small change in this because minus 2 power n. There is a formula like this: n pi plus of minus 1 power n into alpha. இது பார்த்திருக்கீங்களா?
அதான் சார் சொன்னேன்.
இதுல எப்படி வரும்? n substitute பண்றது. So this will go slightly complicated. I will do a small change, okay? A small correction. Y1, instead of taking kx minus omega t, I will take it as omega t minus kx. Both are right. Okay, y2 is equal to, then y2 will be a sine of omega t plus kx. I will take it like this. Then what is y? Y1 plus y2. See, why I'm writing it like this is because it has something to do with leading and lagging. That is how things are derived. Okay, if I put you need to be only concerned about this minus sign. So, but I'm not changing the meaning. This is traveling in positive x direction. This is traveling in negative x direction. So when I say y is equal to y1 plus y2, y will be equal to a into, because I want to write everything in terms of cos. So a into 2 sine omega t cos kx, correct? So this will be 2a cos kx sine omega t. And one more thing that gets satisfied is here also they both are in sine. Here also the output is in terms of sine. Okay. So cos kx is equal to plus or minus 1 is a condition for maximum amplitude. Cos kx is equal to 0 is the condition for minimum amplitude. So cos kx is equal to plus or minus 1. Then what is the value of kx? What value of cos will give you a 1 or a minus 1?
0 and pi.
0. See, for 0 it will give you 1. For 2 pi it will give you 1. For 4 pi it will give you 1. It goes on like that. Similarly, for pi it gives minus 1. 3 pi it gives minus 1. It keeps on going like that. So 0, pi, 2 pi, so on is going to give us what? What will be the general value of this? Is it not n pi? So kx is equal to n pi. K is 2 pi by lambda into x is equal to n pi. Pi and pi will get cancelled. So x is equal to n times lambda by 2. So these are all the points where amplitude is maximum. So with respect to a standing wave, the amplitude is maximum at points called as antinodes. Similarly, for amplitude to be 0, cos kx is equal to 0 means kx is how much? what general solution? Okay, don't tell me a particular solution. What is the general solution of cos theta is equal to 0?
Theta is equal to 2n pi.
2n plus 1 into pi by 2. Odd multiples of pi by 2. So 2 pi by lambda into x is equal to 2n plus 1 into pi by 2. Pi and pi will get cancelled. X is equal to 2n plus 1 into lambda divided by 4. So these are all the points where the amplitude is 0. What is the name of these points? Anybody?
Notes.
Notes.
They are called as nodes. Okay. Then how does a standing wave actually look like? That's what we need to understand. So what are these points? These are nodes. This is a node and this is a node. This is one standing wave. This second standing wave. It keeps on going like this. So it can be any number of standing waves. So I have drawn a continuous line and a broken one, right? The continuous one, if it is the incident wave, the broken one will be the reflected wave. So they both will superpose on each other and it will appear as if the wave is standing at a particular point. That is why it is called as a standing or stationary wave. Now, how is the mathematical condition going to help us? If I take this point as origin, correct? X is equal to n lambda by 2 is what we are seeing. So this is the point of antinode. There is an antinode, there is an antinode. Correct? So with respect to the initial point, at what distance from the initial point will the first antinode be present according to this expression n lambda by 2? X is equal to n lambda by 2. Where will I have the first antinode? If I put n is equal to 1, at how much distance is it from the first node?
Lambda.
Is it not at a distance of lambda by 2? 1 minute, did I miss something? Just a minute, just a minute. Correct. Right. So x is equal to lambda. Are you able to understand? So at a distance of lambda by 2, there is a first node. So where will the second node be? Second antinode be? So what are all the points where you have antinodes? If I put n is equal to 1, x is equal to lambda by 2, n is equal to 2, x is equal to lambda, n is equal to 3, x is equal to lambda by or 3 lambda by 2. Are these points not the points where the antinodes are present? So if you look at this like an x-axis, guys, are you able to understand or is it tough? What is happening? So if I take this as lambda by 2, then how much will this distance be? The second antinode is formed at a distance of lambda. It keeps on going like this. The third one is formed at 3 lambda by 2. It keeps going, right? It keeps on going. So what is the distance between two? This is what you need to remember. Distance between two successive antinodes. What is the distance between two successive antinodes?
Lambda by 2.
Yes. Now, what are all the points where nodes are formed? So x is equal to 2n plus 1 into lambda by 4, right? So x is equal to 2n plus 1 into lambda by 4. If you put n is equal to 0, you will get x is equal to
3 lambda by 4.
n is equal to 0, ma. Lambda by 4. No? N is equal to 1.
3 lambda by 4.
Okay. 3 lambda by 4. N is equal to 2. It will be 5 lambda by 4. So mathematically, what it means is, okay, by the way, what is the distance between two successive antinodes? Sorry, successive nodes. It will be 3 lambda by 4 minus lambda by 4.
Lambda by 2.
It is lambda by 2, right? So distance between two successive antinodes is also lambda by 2. Distance between two successive nodes is also lambda divided by 2. Okay. Wait a minute. Are you guys able to visualize it or not? Is it tough? Are you guys able to understand what is node and an antinode?
Yes, sir.
Everybody?
Yes.
சார் நீங்க டயக்ராம்ல என்ன சார் வரைஞ்சிருந்தீங்க?
Wait, ஒரு நிமிஷம். Wait, I'll show you. See, listen. So he's holding a string at both the ends, no? No, he's making it tight at one of the ends. So he has switched on the frequency oscillator. Now see, no? Are you able to see one dark portion and a light portion?
Yes, sir.
Right. So unfortunately, I can't write on this. Wait, let me try if I can write. No, I can't write. Auto place off. No, I can't write. See, at the left extreme, you're able to see, no, the point where it is fixed. That point is what?
Node.
The point,
Node, sir.
that's a node. The point where he is holding on the right extreme, the point where he is holding is also a node. In between, you're able to see that the wave, actually, how many strings are there? There is only one string, but how is it appearing to your eyes? It is
2
appearing
strings.
as if there are two strings, right? In the middle portion, you're able to see a bigger part. That bigger part is what is called as the antinode. So if you take the left extreme as the origin, from the origin, where is the first antinode formed according to the formula that we have taken?
Lambda by 2.
That's the meaning. Okay. Now see what will happen as he keeps decreasing the length, more number of standing waves will be. You're able to see. Did you see what happened? Wait. Now how many standing waves are there?
3.
3. So 3 standing waves have how many nodes and how many antinodes? Left extreme 1, in between 2, right extreme 1. So 4 nodes and 3 antinodes. So that's what is a standing wave. Now what we are doing is, for something like this being formed, how are we going to mathematically frame an expression and write? Ipar, I'll ask you some questions. You guys tell me. So I hope you visualized it, right? So if I have one standing wave like this, okay. So if this is a node and this is a node, what is the distance between two successive nodes?
Lambda by 2.
Lambda by 2.
Lambda by 2. So middle part you have an antinode. Then what is the distance between a node and an antinode? Take the formula. No?
Lambda by
What is the
4.
distance? Yes, it will exactly be at the center. Purida, the lambda by 4. This is also lambda by 4. So what we will be doing is we will be using this calculation of either lambda by 4 or lambda by 2 to calculate the length of a string. Let's say it's a musical instrument. Let's say it's a guitar or a sitar, whatever it is. We will calculate the length of that string and try to calculate how frequencies are going to get generated from them. So
Sir,
more
but,
number of standing waves. More. Yeah, tell me.
sir, but in the previous diagram, you said that the distance between antinode and node is lambda by 2.
Where?
In this
I never.
diagram.
Oh, I drew it like that. I'm sorry. That's wrong. Sorry about it.
That's an confusion actually.
Oh, that confused it. Okay, sorry. Then a park actually I explained. This is lambda by 2. This is lambda by 4. Now convinced? Now clear?
Yes, sir.
Yeah. So everything I'm trying to talk about is between successive. So if suppose there are two standing waves. Okay, there are two standing waves. Node, node, and node. Okay. So how much is this distance? It is lambda by 4. This distance is lambda by 4, lambda by 4, and lambda by 4. So how many standing waves? Standing wave 1, standing wave 2. It keeps on going. So number of standing waves that are going to get generated, more is going to be the number of such nodes and antinodes that will be formed. Okay. So if you're clear with this concept, I will explain you about the concept of frequency, which is very important for solving problems. Shall I proceed?
Yes, sir.
Okay.
Yes, sir.
Now see, I am going to talk about, so please everybody make a note of this. Standing wave on a stretched string fixed at both ends. Okay. So if suppose, let's say, as I told you, there is a guitar string. If it is a string which is fixed at both the ends and the distance of the, if I take the length of the string as L and there is one standing wave that is formed, okay, then what is going to be the length of the string in terms of the wavelength that is getting produced here? L will be equal to the distance between a node and a successive node. How much is that?
Lambda by 2.
Lambda by
Lambda by 2. And this mode of vibration where there is only one standing wave that is produced is called as the fundamental mode of vibration. Okay. So when I say fundamental mode of vibration, how many standing waves are produced? It is only one. Chariya, L is equal to lambda by 2. So lambda will be equal to 2L. But as I told you, the main application of a musical instrument is to generate a frequency. So how do I write lambda in terms of frequency? Lambda is equal to speed into frequency, that is equal to 2L, which implies, lambda by T, sorry, V divided by F. So F will be equal to V divided by 2L. Guys, you're able to understand? This frequency F1 is called as the fundamental frequency or first harmonic. These are all the terms you need to be careful with. Okay, so please make a note of this point. So it's called as fundamental frequency or first harmonic. Okay, and the value of V on a stretched string is given as root of T by mu. This I will explain later. You need not worry about it. So fundamental frequency is 1 divided by 2L into square root of T divided by mu, where T stands for tension and mu stands for mass per unit length. Or it's also called as linear mass density. Am I clear with this point? Now I want you guys to tell me what will happen in the second mode of vibration. In the second mode of vibration, what will happen? There will be two standing waves. So what will be the length of the string in terms of wavelength? L is equal to the distance between first node and the second node is lambda by 2. The distance between the second node and the third node is lambda by 2. So what is the total length? Is it not lambda? So L is equal to lambda. But lambda is what? V divided by F. So F will be equal to V divided by L. I will write it as 2 divided by 2L into V. V is nothing but root of T by mu. Okay, this is F2. What will be the name of this frequency? It's called as second harmonic, or it's called as first overtone. Please make a note of this point. Correct? So what is third mode of vibration? Tell me fast, guys. For third mode of vibration, what do you think will be the value of L? How many
3
such
lambda.
lambda by 2? It is 3 lambda by 2.
3 lambda by 2.
So that will be 3V by F, which implies F is equal to 3 by 2L. 3 by 2L into square root of T by mu. This is F3. What will be the name of this? It's called as third harmonic, or
Second overtone.
it's called second overtone. These terms are very important. Huh? Don't forget it. Okay. Generally, the harmonic is equal to the mode of vibration. Overtone will be one less than that. So if I talk about the nth mode of vibration, then what will be the value of F4, Fn? Is it not going to be square root of T by mu? If you observe, the denominator 2L is constant. The numerator is decided by the mode of vibration. So it will be n divided by 2L into root of T by mu. What will be the name of this? It's called as nth harmonic, or n minus 1th overtone.
Yes, sir.
Right. So this is all about a stretched string. Okay. So one more important point I wanted to mention is, at fixed points, it's always nodes. So fixed point will always have nodes, in the sense, if you talk about a string instrument has to be fixed at both the ends. So at the end of a string instrument, you will always have a node. Open ends will always have an antinode. Now see. Now comes an important question. If I talk about an organ pipe, open at both ends. So organ pipe means you can think of a small tube like this, where it is open at both the ends and sound is flowing through this such that you're able to hear some sound from it. So if I talk about the fundamental mode of vibration, you should still have So when I talk about the fundamental mode of vibration, if I take the length of the organ pipe as L, this is an antinode, this is a node, and this is an antinode. Correct? So how much will this distance be?
Lambda
By? Lambda by?
4.
Very good. So this will be lambda by 4. So L will be lambda by 2. Correct? If you do all these things, you can calculate and see that the fundamental frequency in this case is 1 by 2L into V only. V in the case of an organ pipe is given by the expression root of gamma P divided by rho, where gamma stands for the adiabatic constant, P stands for the pressure in that medium, and rho stands for the density. So what will be the name of this frequency? It's called as fundamental frequency. Correct? Now, when I talk about the second mode of vibration, how many standing waves should you have? 2 standing waves. Half on the left, half on the right, and one complete in the middle. So this distance is lambda by 4. This distance is lambda by 2. This distance is lambda by 4. So if you calculate the frequency, F2 will come out as 2 divided by 2L into root of gamma P by rho. So what I'm trying to conclude here is, they're able to understand. In the case of a string which is fixed at both the ends, the fixed points have antinodes. The place where it is open, fixed end had nodes. Whereas when it is open at both the ends, you have antinodes on both sides. So in this case, what will be the nth mode of vibration? Fn will be equal to n divided by 2L into square root of gamma P divided by rho. Correct? So this is called as nth harmonic or n minus 1th over tone. So the questions will be framed based on this. Next is a closed organ pipe. Before we see what's a closed organ pipe, I just want to show you one application based on this concept. Let's do the second problem. So there is a string which is 2 meters long and fixed at its ends is driven by a 240 hertz vibrator. The string vibrates in its third harmonic mode. The speed of the wave and its fundamental frequency is given by. So what have they told her? So length of the string is how much? 2 meters. Frequency is 240 hertz. Okay. Now tell me one thing. What is the relation between the string vibrates in its third harmonic mode? Correct? So when it is vibrating in its third harmonic mode, F3, that this is F3, correct? F3 is 240 hertz. And what have they asked? They have asked the fundamental frequency. Now tell me one thing. What is the relation between F3 and F1? Look at the equation. If you observe, 1 by 2L into root of T by mu is the same. Second mode of vibration, the numerator is 2. Third mode of vibration, numerator is 3. First mode of vibration, numerator is 1. So F3 and F1 will be
F3
3
is
F1.
equal to 1 by 3 F1.
3 times. It's more. Yana 3 is in the numerator. Puridama. So the harmonic increases, the frequency increases, which implies 240 is equal to 3 times F1. F1 is how much? 80 hertz. They're asking the fundamental frequency. But unfortunately, I have 80 hertz in both. So since they're saying the speed of the wave, to my guess, the answer should be B because, why should it be B? Because the speed of the sound is 320 meter per second. But let's try to find it out, okay? So F3 would have formula another. It is 3 divided by 2L into VR. You need not use root T by mu. So 240 is equal to 3 divided by 2 into 2 into V. It is 80. 80 into 4 should be equal to V. V is how much? It is 320. Guys, am I clear?
Yes, sir.
Okay. So this part alone, you need to practice a lot. So, did you guys make a note of all the concepts that I've discussed? So, did you write down all the concepts that we discussed with respect to standing wave? Everybody?
Yeah.
Okay.
Yes, sir.
Now that's it. So I'll stop with this for today. And I wanted to discuss about the math timing. See, for math class, I don't have time to schedule at all because everybody's schedule is occupied. Till now, we had the class from 7 to 8:30, but I heard that some of your schools are starting by 8 a.m. itself. Means you have to be in school by 8 a.m. So the only option that is left out is to prepone this by an hour. Okay, listen to this. So it will be from 6 to 7:30. I know it is difficult, but I need your cooperation for the 20 to 25 days. That's it. We'll be done with the syllabus. Then things will be back to normal. Okay. This is the only time that is available. The schedule is already ready. I'm going to post it in the group today. I want you all to be mentally prepared with this. I'll start from Monday. I'll ask her to take from Monday. There's the only slot that is available. No other slot is there. If I put any other slot in the evening, you have to sit for 6 hours continuously, which will be a literal torture, I understand. So at least if this is there, you have to just wake up 1 hour early and then you can do your work. You'll at least have a break of the school and you'll have some break before 3:30, or else I have to start the classes from 2, which is not possible. And I don't want you to take so much of stress also. Okay. So this is fixed, guys. Any other doubt from today's class?
No, sir.
Okay. Then we can wind up. Just a minute, okay? I'll take attendance and